What's up, everybody? Welcome back. Patrick here. Moving on to the next question. We are given two functions and we have to figure out these columns for both of these functions. So we have to figure out, is it a growth or a decay? What's the initial value? And then what's the growth or decay rate? Now, if you remember from the lecture videos, in general, these problems take this kind of format. Right, so you have your initial value times 1 plus r. This r here is basically your rate of either growth or decay. If that r is negative, it's a decay rate. That r is positive, it's a growth rate. Then we have our initial value, and then when you multiply those, you get your final value. So let's start off with this first function. Let's write it under this general format. So we have 120 times 1.03 to the power of n. So notice initial value, we could tell it's 120. We could fill that in right now. Now, is this a growth or a decay? Now, I would actually figure out what the rate is first, because if that rate that we solve for is going to be positive, we know it's going to be a growth. If it's negative, it's going to be a decay. So we can say that 1 plus r has to equal 1.03. And when we isolate for this r, bring this 1 over, we get 1.03 minus 1, which is 0.03, positive 0.03. So right there we know that we are dealing with a growth scenario. Basically, if this 1 plus r, this whole bracket, is greater than 1, then you're dealing with a growth scenario. And notice that 1.03 is greater than 1. Right? So 0.03 is our growth rate. And that's in decimals. If you want to convert it to percentages, you multiply it by 100. So this would be 3%. Now, one thing I want to mention, you want to be careful for scenarios where you maybe have like a whole number. So let's say this was like 2. We mentioned this in the lecture videos as well. You would make that 1 plus r equal 2. And then when you isolate for that r, you would get 1. But that 1 doesn't represent a 1% growth rate. Remember, this is in decimals, so you got to multiply it by 100. So if the bracket is 2, it actually represents a growth rate of 100%, right? 1 times 100. Right, so just always remember this r you solve for, it's always in decimals. Even if you get a whole number like this, it just means it's growing really fast. And this could be anything. This could sometimes be a 3 or a 4, right? Then that growth rate is going to be very high. So always remember to multiply this r by 100 to convert it to percentages, even if you get whole numbers for the r. Anyway, so first function, we are done. What about the second function? So we got 2500, 0.95 to the power of t. Well, from here we could tell initial value 2500. And then let's solve for that r. So 1 plus r has to equal 0.95. Bring the 1 over, we'll have r is equal to negative 0.05. So from here, because that r we solve for is negative, we know that we're dealing with a decaying scenario or a depreciation scenario. And the decay rate is going to be negative 5%, right? If we multiply this by 100 to convert it to percentages. Basically, when this 1 plus r, when it is between 0 and 1, right? So 0.95 is between 0 and 1. Then you know you're dealing with a decay scenario, right? So anyway, these two functions, those are the characteristics.